welcome you all. So today's lecture is on numerical problem based on specific optical rotation. So in this topic, we will discuss about the numerical problems which is based on specific optical rotation. But before that, here we will also would like to understand and would like to learn what is optical activity, what is the plane polarized light or plane polarized light beam, and we will also see what is the polarimeter by which these rotation or these optical activity can be checked or can be investigated. And then we will come to the problems which is based upon the specific optical rotations, and we'll see how there are different optical rotation is there, and on the basis of different numerical problem we will be able to see what type of particular kind of enantiomer is there. And also we will see in case of the racemic mixture and optical purity, how much optically pure compound is there. And with respect to the racemic mixture, because there are the enantiomeric axis, and with respect to enantiomeric axis we will also see how that can be calculated on the basis of certain certain principles, on the basis of certain way of uh, calculating them. So here, before we see, we will start from what is optical activity and what does this means. So enantiomer are non-two same physical and chemical property, but they differ in their way they interact with a plane polarized light. Because as you already studied in earlier lecture, we discussed about the different nomenclature like dextrorotatory, levorotatory, and similarly rectus, signature, and their rotation with respect to the plane polarized light. So here the enantiomer, obviously they are having the different rotation with respect to that plane polarized light. So here the substance which can rotate the plane of polarized light are said to be optically active, because they are optically active, they are rotating with a certain angle. So here, like dextrorotatory means right is indicated by plus sign, levorotatory means left and is indicated by minus sign. So those substances which do not rotate the plane polarized light are called optical inactive. So here you can see dextrorotatory, the new form of representation or new form of indication is represented by plus, and is an older way of representation is minus or d minus. So similarly, in case of levorotatory, it is designated minus, and older convention of representation is I minus. So these rotate the plane polarized light towards the left direction. So on the basis of that, these dextro rotation and levo rotation has been designated. So this is how we can see here. So before to check how the that is dextro rotatory or levo rotatory, the different enantiomer. So before that, you all might be aware of that. What is the plane polarized light? As you might be very confident with these terms. So if the electric field vector are restricted to a in a single plane by filtration of the beam with specialized material, then the light is you can say as a plane or linearly polarized with respect to the direction of propagation. If it is directed towards in a specific direction, so along their way, so that is linearly polarized with respect to its direction of propagation. And all waves vibrating in a single plane are termed plane parallel or plane polarized. So here the plane polarized light is all about this. So you can see here the principles of the plane polarized light. So we can discuss how the plane polarized light can be can be seen here from we will see this from this simple way of designation, simple way of representation. So by this way we can see here how does this light, there is having a all the directions, this is called unpolarized light. So if we are passing this light in a unidirectional or towards the having certain single direction, so this is having a modulation, you can say this is moving like this zigzag motion towards their plane. So when it moves towards a one unidirectional, then it will called as a plane polarized light. But like in a case of bulb or any the light source which is releasing the light in all the direction, so here in case of polarimeter polarizers, this polarize the light towards a unidirection, and this is having the there are specific wave which is passing in per second, that is the distance which is lambda, you can say already these things. So this in polarizer, this light is modulated like in a way this is propagating towards the one towards the unidirections, so which is called plane polarized light. So in polarimeter where we generally see how does the atoms are behaves with respect to in case of chiral molecules, once we see the samples whether that is having dextro rotation or levo rotation. So here these atoms or molecules, they rotate the plane polarized light with a certain angle, and on the basis of that angle, either on which direction that angle is being being watched. So on this here the sample is being kept inside you know the specific there is a sample tube. So this is plane polarized light which is passing from the particular tube like structure here, you can see. So by this way the sample is being investigated in the polarimeter. So that polarimeters helps us to see their optical activity towards the plane polarized light. So here by this way we can see how does the polarimeter works out. So if you see this, as I said, this distance rho and Christ, you know that the distance which is represented as lambda, you all might be know this single ray of photon, if it is going towards like in a one direction. So this is a plane polarized light. So if it is having all the directions, then you can see here this is called non-plane polarized. Sine waves are not aligned in the same plane, so this is unpolarized beam. So frequency also now can be easily calculated by speed of light, and once you will divide it by the wavelength, so you will get the frequency. So that can be calculated easily. All the wave rays in the beam align in the same plane. If you see here, so the waves are aligned towards, you know, on the same line, which is can be explained in from here. If you see the movement of the waves of the light movement, so this way the plane polarized light, as we said, can be, you know, can be understood. So here this the sample cell from where this incident polarized light is being passed, where means here you will put your sample which is having for the you have kept for the examination, you know, either the molecular rotation is dextrorotatory or levorotatory, or to check the their optical activity. So you have to keep your sample inside this tube-like structure, which is called as a sample cell. So the transmitted light is rotated towards with in a certain angle, which is rotation optical, with an optical rotation with respect to that particular light. Plane polarized light is represented as alpha. So this is designated as alpha with respect to the plane polarized light. So this is the transmitted light rotated. So uh, yes, here you can also watch it with in another way as well. Here, like in case of sodium lamp, which is having certain, you know, lambda value, sample cell, so observation with respect to certain angle can be watched out. So on this you might be already know, because this like chirality, enantiomer and diastereomers. So how can we put them to designate in a different chirality means this is having the which enantiomer, we can designate them on the basis of that. So here the angle of rotation, which is very important, is the angle degree by which the analyzer is rotated to get maximum intensity of light. Is generally depends upon the many factors. Among them, the most important is nature of the substance. What type of the substance nature is, that is very important. Concentration is also equally important. At how much concentration, like in case of gram per ml, how much gram you are taking, so that angle, this angle of rotation, you know, is having the certain condition, and this will depends upon these factors. So length of the polarimeter tube, or in which tubes you are keeping your sample, that will also matter here. So lambda of the incident monochromatic light and temperature of the sample as well is equally important to analyze this. So these are certain conditions we can say which is important to the plane polarized light. So specific rotation now comes to another here. What is the specific rotation is? So it is defined as the number of degree of rotation caused by a solution of 1 gram of compound. If you are just checking the number of degree of, you know, the rotation which is caused by a solution of 1 gram of compound, if you are taking 1 gram of compound per ml of solution in you might have seen in a chemistry laboratory. Generally you can easily prepare these kind of solution in terms of in a different unit, but here you have to keep in mind the unit which has been given to define it, like 1 gram in 1 ml of, or per ml of sample solution, or in a solvent you are dissolving it or taking it. uh, in a polarimeter tube, which is the length is being given here in 10 centimeter, or you have to take, once you are to going with a numerical problem, so you have to take in a decimal unit, decimeter unit. So long at specific temperature and wavelength, whatever is the specific temperature and wavelength for to analyze that sample. So the specific rotation is calculated from observed angle of rotation. As you know, this is the sample relationship, specific rotation with respect to lambda t naught or t, temperature in degrees. So here that is alpha upon LC. So here the alpha is specific, it denotes the specific rotation, T degree temperature of the sample, lambda wavelength of the incident light, where the sodium D line is used, and lambda is replaced by sometime D. So here you can also replace this lambda, because here you are taking sodium, or the D lines or sodium line. So you can replace this lambda with the designate as a D, and alpha observed angle of rotation, length of the polarimeter, in a decimeter you have to see, and concentration, as already we have discussed, being taken as in gram per ml of the solution. So by this way, you can see how to specific rotation can be calculated by keeping in mind this equation, this simplified form of equation, and by designating or by keeping in mind what is the spatial these terms are having, what is the relevance once you are calculating the specific rotation. So before that calculating, you all must have to keep in mind the exact definition, because here is very important, and it's a very simple definition by which you can keep in mind this relationship, and on the basis of this relationship you can easily calculate the specific equation. So here the form, that equation form can be converted here. In place of lambda you can replace it by d, and this is will be equal to alpha upon cl. So as we said, the all these terms are having the convention as the nomenclature, as their usual meanings, as we already discussed. So this equation corrects for differences in the cell length and concentration. So the specific rotation calculated in this ways, physical property of an optically active substances, you always get the sample value of alpha dt. So in most of the numerical problems, once you will calculate the numerical problems based upon these specific relation. So this can be mostly in a competitive national level examination. After the master's degree, there are different kind of question they are will ask in competitive exam. So that also is this equation is being they mention in a problems, and then you have to not confuse with the previous what we discussed. So here these all are having other having the usual meanings of these specific terms is having their usual meanings. So if you see, there are number of compound their lambda d, alpha d value, which specific rotation for their value is given here. So like in case of compound, these are mostly the bioactive compounds, and these are natural product compound like cholesterol, cocaine, morphine, codeine, heroin, ephedrine, and progesterone, testosterone. These are hormones, sucrose, sugars here, glucose, and insulin. So these are having the specific rotation value is given here. So these are the specific value with respect to the each and every compound. You can see from the reference value, these are the reference value. So these are calculated by the way which we had already had a discussion on that, how to calculate it. So on the basis of that, these standard value has been calculated uh, from the said discussion what we had so far. So these are the reference table, and you can keep in some of the examples how much the specific rotation is like in case of specific like morphine or codeine, whatever the specific rotation of these, so you can remember these things. Now coming to the numerical problems here. These are very important numerical problems by which we can find out the specific rotation by the numerical, as we said is before. No numerical problem we had discussed many other sub intangible characteristics or the things which is required to before to coming to this. So like here the example is like 0.5 gram of an optical active compound was dissolved in 2 ml of solvent at 25 degrees Celsius. So the solution was kept in a cell of 10 centimeter, and the observed rotation was seen like plus 10 degree. So the calculate the specific rotation of its enantiomer. So such kind of problems we can easily can calculate once you know what is the meaning of optical rotation, what is the meaning of specific terms which we had discussed so far. So here it is given like observed rotation is given on alpha, that's a 10 degree. Length is given in centimeters, so you have to convert it into decimeters. So as you know, 10 centimeter equal to 1 decimeter. So these are very basics very basics concepts once if you know, and basic concept and conversion, unit conversion, if you know, you can easily put the value on the relations. And concentration is also given 0.5 gram in 2 ml. So gram per ml we had already discussed in the definition of the specific rotation once we studied earlier. So here specific rotation can be alpha can be calculated, specific rotation with respect to d, and with certain degree can be calculated by putting this value in this here. So you will see the specific rotation is being plus 40 degree, it is calculated now, and this is comes by multiplying all these value by putting this value, and after the solving this, uh, so you will get the specific rotation of that particular compound. So here another problem which is also very important with respect to what we discussed so far, like here calculate optical purity of a sample of 2-bromobutane has been given, whose enantiomer has specific rotation. Actually this form is this enantiomeric form has a specific rotation when it is exposed with the plain polarized light in a polarimeter. So that is 0.223.1 degree, and when observed specific rotation was seen plus 9.2 degree. So you all know optical purity, you might have been aware of this simple relationship from your previous lecture and previous in your classes, that optical purity is represented by this equation, optical purity equal to observed specific rotation divided by specific rotation of pure enantiomer, and once you are calculating in percentage you have to multiply it with the 100. So by this way this will be will this value will come once you will calculate this will come 40. So this 40% optical purity of the mixture is indicates 40% enantiomer of plus enantiomer, and there is always, if it is coming only 40%, then obviously there will be 60% enantiomers will be having racemic mixture, and this is in a mixture form. So racemic mixture means this could have a equal proportion of one form and another form, plus and minus form, like in case we designated D and L. So here in a new convention you can represent, as we said, plus and minus. So the same here, if you listen the lecture properly, so you can remember here why this is represented like in this way. So if you see this 40% plus and 30% plus will be, because this will be the equal amount, so this equal amount we have to the equal amount of percentage of the specific rotation of that particular enantiomer. So this is 70% enantiomer and another one will be 30% enantiomer. So there is, if you see the axis, what is axis means, because here 30-30 is common for both, that's why this will be having a one just opposite to each other rotation, but only the axis is this 40%. This 40% total is the axis in that mixture, so this is called enantiomeric axis. So by this way you can see there is 40% axis of one enantiomer in this overall. Once we had seen this, if suppose any sample you have and you are calculating this all, so that sample is having 40% of a particular enantiomer higher than the rest of the mixture. So because 30-30 will be cancelled if you want to just one having clockwise direction and then the anti-clockwise, so they will just cancel out, but only 40% will, which is having in excess in that solution, will be seen over there. So now another terms which is very important also is molecular rotation. So here the molecular rotation which is preferred over specific rotation, and it is given by the simplest way or simplest way of representation by m lambda 2 t naught equal to t degree, you can say alpha 2 lambda t degree multiplied by m upon 100. So here what is the terms is specific meaning. So specific meaning of m is having here is molecular weight of the optical active substance, and here utility of specific and molecular rotation is just like other physical constant such as melting point, boiling point density, refractive index, etc. Also a characteristic property for establishing the identity of a optically active compound, and it is intensive property. So these are some of the characteristics, but here the more important is when we see the molecular uh, molecular rotation. So molecular rotation can be also calculated by putting, if you have the value of alpha and mass and molecular weight of that particular optical active substance, so by putting this value you can find out the molecular rotation as well. So this designation or this kind of numerical problem can also be can be done with the help of this simplified way or this simplified manner. Another here, if the your mixture is having equimolar mixture of an enantiomer, means if I suppose plus 50 and minus 50, so the rotation will be that will be 0 in that case, because each and every of the enantiomer will rotate with equal degree of angle in each other, to opposite to each other, so that this alpha will specific rotation will be come 0. So the effect of each molecule is cancelled out by its enantiomer. So racemic mixture, as we seen in case of the previous the numerical problem we had seen, there are 60% of the the mixture we had got, which is having plus 30 and plus minus 30 enantiomer, means D D30 and D minus L30. So that is each is having opposite rotation with each other, so they will cancel out from one another. So that's why that is having 40% of enantiomeric axis in case of the previous example we had seen in the lecture. So here you can see many more example, like in case of tartaric acid, this is having alpha D minus 12 degree, and in plus tartaric acid this is plus 12 degree, and melting point, you can see the melting point is almost similar here. but the rotation with respect to the optical or plane polarized light, they will rotate in a left hand side, and this is right hand side to the plane polarized light. Solubility of 1 gram in 0.75 ml water, so solubility is also similar. So you can see the properties almost similar here. 0.7 ml methanol, and 250 ml ether. So similarly, the solubility in terms of, you will see the properties in terms of melting point, solubility. So this you will see is same, and if you see their density also is similar. So the most of the property, if you see their physical property is same with respect to the different solvent, with respect to, if you see their density as well, but their optical rotation is different. They are optically obvious, they are optically active, but their rotation with the plane polarized light is different. So this is what we see here with the help of different, with the help of a numerical problem. We also seen that, so that can be explained from there as well. So there are many more examples like tartaric acid. So from here you can see mesotartaric acid, because mesoform is having equal proportion of plus minus, so that will be having the specific rotation net will be cancel out. So here you can see their property like solubility in this much, and density, melting point, and insoluble in methanol. In case of, if it is the same compound is having the mesoform, so in that case they are insoluble. Also the property will get little bit changed. Here this is required 0.75 ml, and here it is required only it required more ml of water. And you can also see the melting point is also different from this one, so the property is getting changed in case of mesoforms with respect to their different enantiomer. Now from the overall discussion, if you see, we had a overall discussion about optical, optical activity. We also discuss about the plane polarized light, about the polarimeter, what are the principle of polarimeter, specific rotation, optical rotation, and numerical problems related to that. And after all over discussion, you had seen that how the enantiomer, and what is the enantiomeric axis, what is the racemic mixture, how does the numerical problem can be done on the principle of the basic concept of optical active compounds. How can we see in a numerical way to calculate their individual enantiomer and racemic mixture, and how does their properties are having the specific properties. So after overall discussion, there are number of questions can be framed out here, like what is the or explain the optical activity and write a note on plane polarized light. There could be some question can be made from the overall discussion, like write a note on polarimeter, differentiate between racemic mixture, enantiomeric axis with certain example you can take on this. So this kind of question is overall is very important. So overall, this material is taken from the various sources, various books and internet sites, and this material is only for the instructional purpose, and having no other use, only for the instructional purpose only. And there are number of reference book has been taken, textbook has been also taken to see to make the this content. So I thank you all for watching this videos and listening this video content. So thank you to all. Thank you so much.